All right, the next complication in naming organic compounds, naming hydrocarbons, comes whenever we have hydrocarbons, whenever we have branches. And so what you have to do is you have to figure out what the longest chain is. So if I'm just drawing backbones, just because it's easier and I'm lazy. So let's say I have these, and I've got a carbon here, and I've got a carbon there and there. You see how those are all connected? My job is to find the longest chain, the continuous chain. It's like one of those games where you don't pick up your pencil kind of thing. Can you cover them all without picking up your pencil? And the longest chain obviously starts off here, but notice when I get to this carbon, if I go up, I can grab 2 more carbons, whereas if I went to the right, I could only grab 1 carbon. And so there are 7 carbons in that chain. It's all single bonds. I haven't drawn any double bonds. And so 7 would be heptane. So the last part of this hydrocarbon's name is heptane. That is the end of it. Here's the name of it. I'm going to be building to the left of the heptane once I've identified the longest chain. Now I look at the substituents, or the branches. There is a carbon here and a carbon here. 1 carbon, if I just had CH4, I have memorized, or I have that table handy, that's methane. So a carbon group, which would only need 3 hydrogens because the other 2 electrons are forming the bond to the chain, this is called a methyl group. So I change the ending to methyl. So there are 2 methyl branches on this chain, which means I have a dimethyl heptane. So I'm building the name. I have a dimethyl heptane. And then the last step would be to number where those 2 methyl groups are. The di is 2. The methyl is because they're a methyl group. And I want to number the chain starting at one end and going to the other such that the numbers are the smallest possible. Now, the way that I've numbered it here, this would be a 4 and a 5. But if instead I number it the other direction, so 1, 2, 3, 4, 5, 6, 7, I still see my 7 in a row, but now it's a 3 and a 4. So it's 3,4-dimethyl heptane. That is the name of this compound. Let me squinch that a little closer. This is 3,4-dimethyl heptane. So naming these long chain hydrocarbons is just a matter of sort of putting all those pieces together. So let me give you another 1, 2, 3, 5, 6. All right, so there, and let's say I have there, and there, and there. All right. Now, again, I want to find the longest chain, and in this case, it is drawn straight across, but be careful. Sometimes it might not be. Notice as I got here to the end, let me grab the pink, I could have done this, and that's exactly the same long chain. All right, that's exactly the same long chain and would get me exactly the same answer. But I'm going to stick with the yellow, and then I'm going to look at my groups hanging off of it. All right, and then I'm going to number. And I'll just number here. I won't worry about which direction I'm going yet. 1, 2, 3, 4, 5, 6, 7, 8. So this is an octane. That's the end of it. There's the name of my compound. Octane is the end. I have an ethyl group. This is an ethyl, and it's ethyl because 2 carbons is ethane, so a 2-carbon branch is ethyl. And I have a methyl, and I have a methyl. So I have a dimethyl and an ethyl. Now these are typically alphabetized when you put them together for the name, but I'll never test you on that. Ethyl becomes before methyl. We don't worry about the di when we're alphabetizing it. So this is an ethyl dimethyl. I'm leaving a little space because I have to number where these are. So this is an ethyl dimethyl. The ethyl, if numbering it this direction, is in the 3 position. The dimethyls are in the 5 and the 7 position. But what happens if I number it the other direction? 1, 2, 3, 4, 5, 6, 7, 8. I still have 8 in a row. Now the dimethyl is in the 2 and the 4, and the ethyl is in the 6. That's a smaller set of numbers. And again, I'm not going to try to fool you too much with that, especially as it gets this complicated, but that's why I number it that direction. So the dimethyl is in the 2. I get rid of these numbers. The 2 and the 4 position. So this is a 2,4 dimethyl. And the ethyl is in the 6 position. 6-ethyl, 2,4 dimethyl octane. If there is a double bond and some branches, it's not that much more complicated. All right. Put a double bond there. That still needs something. All right. If there is a double bond and some branches, again, I want to find the longest chain. I want to make sure the double bond is part of that chain. And again, it can get complicated. I'm not going to make it too complicated. Notice that if I just went straight across, that's not the longest chain. But if I include these two, now that's the longest chain. So there's my longest chain. Here it's a little easier to number because when there's a double bond, that takes precedence over the branches. So I number it so that the double bond is the shortest. So the double bond, if I number it starting at the top, 1, 2, 3, 4, 5, 1, 2, 3. So I'm going to number it backwards here so that the double bond is in the 3rd position. 4, 5, 6, 7, 8. This is also an octane, except for it's not an octane, it's an octene. And the octene is in the 3 position. That's where the double bond is. And then I have a methyl and another methyl. So this is also a dimethyl. I'm using a lot of dimethyls. So this is a dimethyl 3-octene. And the methyl groups are in the 3 and the 6 position. 3,6-dimethyl 3-octene. You will not have to generate names from scratch, but you will have to maybe pick them out of a lineup. So just kind of break it down that way, eliminate the ones that are obviously wrong, and then try to look around and see which ones match it best.